Hello once again. So, yeah, you already presented me, but I'll repeat one more time. My name is Eugene Rodygin, and I'm one of senior developers on the Blend4Web team. For my today's presentation, I decided to choose such a loud topic. Anyway, I hope and I believe that this can be helpful for anyone who uses Blend4Web. So Blend4Web features you've never heard of. You know, guys, that Blend4Web can be used in a great variety of different applications, starting from simple portfolio pages where you can demonstrate your 3D artwork, up to very complex applications like 3D configurators and the most complex applications, in my opinion, like games. And in order to satisfy all the needs caused by these applications, we try to develop a great variety of different functions. And for various reasons, sometimes they can stay in shade for quite a long time. And I'm going to fix this for you and cover some of such features. And maybe some of them are just maybe ways you should do. It's better to do some things. So. Let's start with a quick overview of what I'm going to cover in this presentation. I'll divide my speech in 4 parts. So first of all, I'll speak about project management, some topics which can improve your workflow with Blend4Web. Next, I'll show you some hints which can be used in Blend4Web's logic system, including logic nodes and JavaScript. Then there will be some interesting topics regarding rendering. There are also some unfairly forgotten features there. And I'll finish with my favorite topic. It's profiling your application. So applications made in WebGL should be really carefully optimized. Okay, in the project management section, we'll speak about converting resources, texture compression. I assume that you have heard about it previously, but maybe, and I'm sure some of you wondering why do you have to use it. Then I'll speak about media formats conversion, about very important mode introduced somewhere maybe half a year ago. It's minimum capabilities mode, and I'll finish with some interesting comments you can use in a command line project management system. So you might be wondering, if we have specially prepared for the web image formats like PNG or JPEG, why do we have to use something else like DDS textures or so-called PVR textures? So here is just a small demonstration which tends to answer this question. I decided to run the farm application, which I'm sure all of you are familiar with. And we have 2 charts. On the left, we can see what happens when we do not use DDS textures with frames per second. So we have something like 110, I suppose. Immediately when we convert most part of the textures to DDS, we get an increase of, so let's say, 10% and almost hit 120 frames per second. But even more magical things happen to memory usage of textures. When we do not use compressed DDS textures, memory consumes something like 300 megabytes of memory, which is a really great amount for web application. When we use DDS textures, it drops to almost 100 megabytes. So I think the difference is incredible. My suggestion, when you're releasing your application, the final version of your application, you definitely have to convert textures to DDS, and you'll find it later, to PVR textures to use with Apple devices. So how to use resource converter? I'm sure you're aware of the option convert resources. You need to have some dependencies installed. They're described in our documentation. And then when you click convert resources, Blend4Web's project manager will automatically convert all the textures to DDS and PVR if their dependencies are meeting the requirements. So, and then we just need to select several flags inside our application during initialization. So you just need to use assets DDS available and assets PVR available, and maybe assets min50 available, which are just smaller versions of your textures. This will give a great increase in the performance of the file application. So next, when we speak about playing video or audio files on the web, there are also some media formats specially prepared for playing inside browser. For example, WebM, it is getting more and more popular in the recent years. Also, there is an OGG, a very, very popular format, but the sad part is that not all the browsers work with these extensions similarly. So you might come in a situation when your beautiful music, WebM music, is not played in Safari and Internet Explorer, and it has only partial support in Android browser. The same can be said about OGG. It's not supported in Safari, Internet Explorer, and Edge at all, unless you are using some extensions available out there. Resource converter again. If you have the needed dependencies, you can click Convert Resources, and you will get your WebM and OGG files automatically converted to MP4 files. So here's a small screenshot from the project converter. That's it. So next interesting feature is a minimum capability mode. You might know that WebGL and hence Blend4Web work, they should work similarly on the whole variety of devices available out there, starting with your modern PC with Core i7 and GeForce GTX 1080 on the board, and on the phones. But obviously they have different hardware capabilities, and the application just cannot work similarly. So in this case, how can we say that the application will run, let's say, on iOS? The short answer is there's no way. You definitely need to check it in real life. But we can make a good approximation. So here we have a minimum capability mode. What does it do? It simulates the really weak hardware with the minimum requirements to run WebGL, and thus, if your application is has quite heavy shaders or some very complex animation, you'll see errors in the console, or just your shaders will not compile, and you'll see angry pink shaders on the screen. So you can turn on the minimum capabilities mode inside your initialization function, or which is easier for artists, you can just use the debug section available in the viewer application and choose minimum capabilities mode under the debug section. Yeah, this is not very popular topic, but you can work with your project, use Project Manager inside the command line. I've just decided to show you two small functions which cannot be, which deliver functions which cannot be achieved with Project Manager, web version of Project Manager. So you can run development server outside Blender. You just need to run the project server script, and thus you are independent of Blender. So you do not need to run Blender in order the Project Manager to work. Sometimes it's really useful, so you don't have to watch if Blender is running or not. So you just run the script and it runs on background. Next, you can deploy your project not into zip archive, but to a folder, which many of our users were asking for. So this is done with this simple command down there. You just need to point the new dir, and the project will be exported right there. And don't forget to build it previously. So, and in order to use this function, you need to check the copy management script flag when you create your application. Now about application logic. The first thing, you might be aware of it, but it is not still very popular. You can combine your logic nodes with JavaScript. So for this case, we have a JS callback function. The perfect example of using this kind of interaction is the Pythagore-style third, if I'm not wrong, level. So almost all the logic with character movement is done on the JavaScript side, and then implemented inside the logic nodes tree with the JS callback function. You can deliver any required variables to this function, and with the out params field, you can get anything you want from your programmer. You just need to register a special callback. Everything is described in the documentation as well, in the logic nodes model. Sometimes our users are not satisfied with the predefined settings which we give with low, high, and ultra quality. Sometimes they want something special. Let's say turn on very strong anti-aliasing, or maybe disable shadows and enable reflections, and so on, different combinations. You can do this, first of all, you can check the type of device with, for example, this I have a small mistake there. Okay, with these functions main check mobile, which obviously will say if your device is mobile or not. And the last one, it should be test performance. I missed one letter. Debug test performance. Depending on the output, you can disable or enable some features. Then you just need to send the config p custom quality to the app initialization function. And previously, you have to set with the config model all the required options you need. Here we can see MSAA samples set to 16. So you can get all the quality combinations you want. So now a more interesting part of my presentation, it's rendering. These are 4 topics I decided to choose for this presentation. Mixing cycles nodes, rendering to texture. I've never seen our users using this feature. I'll show you how to use that offset. Also, it can help significantly when you're dealing with transparent objects. And the thing which I was working for a really long time, and actually it was inside Blend4Web even in 2015, 14. Yeah, but it's not really popular, maybe because of its complexity. We should make it simpler. Anyway, I'll show you it. So this kind of trick is arguable, because maybe some of our artists will blame me for this use case. But anyway, you can combine cycles and the Blender internal nodes together and get something like this. We're using Fresnel node and environment texture from cycles with reflection output inside the Blender material. So we can get something like PBR in Blender internal as well. So this is Fresnel node used with Blender internal. That's possible, and you can combine nodes in any way you want. Next, rendering to texture. When can be this useful? On this simple screenshot, you can see that you can quite easily, well, actually very easily, render a part of the scene or even another scene into the texture and put it into some object, like a texture. For this case, you have to use the non-type texture and select under the source type section the scene. Then just point the scene ID and use this texture as a color one. And don't forget to use UVs, I mean texture coordinates for the object you're putting the texture on. This can be really interesting. Maybe you need a transmission on the TV of something happening in the other side of the map. I don't know. So this is a tricky part. As you know, Blend4Web, WebGL are using OpenGL and DirectX as a backend to render all the stuff on the screen. And having all their advantages, there are also some disadvantages as well, of course. For example, rendering transparent objects directly is quite a hard task. Though in the next presentation, Alexander will tell you some interesting facts about what we are going to do with transparency in the near future. Anyway, now we have something not really convenient, and sometimes you can come into the situation like we can see on the screen above. So the ecosphere is rendered last, and Susanna is rendered first. Thus, though these objects are transparent, we can see nothing behind the Susanna, because it just was rendered first. this is how the 3D graphics work. So in order to avoid this, sometimes, of course not in all the cases, you can use the depth of set for transparent objects. And yeah, it can be set up in the materials section. And just reorder the required objects, changing the depth of set option. Now, about dynamic water. I think I have to show you a small demonstration. We have plenty of time, I suppose, yes? Yeah, I'll just show you it. Can you turn on the microphone, the static one? I mean, this. I hope this will work. And something's wrong. Anyway. Yep. So here we go. This is a water surface, and it has a dynamic surface. And an interesting part is that it works with physics. So these cubes are floating above the water surface. It is affected by wind, something like that. And an interesting part about it is that it is actually an unlimited surface. So when you click this option, yep, here it goes, water, and then switch the generate mesh, you get the unlimited surface where you can set up the number of cascades and subdivisions. Also the distance which the water will be visible on. So we can just scroll somewhere, and it actually an unlimited surface. You can scroll wherever you want. It will not end up, because these are cascades. Here's our island. And all this stuff supports physics. Yes. So, and actually this works quite fast, because physical part is being processed in the worker, so in the separate thread. So I suppose this can be helpful also when you are rendering wide terrains, as we were discussing in the whole. Yes, that's it. I love this feature. I don't know what about you, but anyway. And I want to end up with my favorite topic. It's profiling. So last year I was speaking about the most common approaches to determine the bottlenecks of your application, and I have covered almost everything. But a year ago we introduced a new debug mode. It is called render time. So this is what it looks like. Maybe you have switched to this mode previously and was wondering what are these colors supposed to mean. So the redder the color is, the heavier the rendered object is. So this is a screenshot from the Pettigor's Tale game. And obviously terrain has to be optimized, but nevertheless it takes the biggest part of the screen, so maybe it has to take the most of the time to render it. So render time is a perfect solution to determine the most complex shaders in your application. Anyway, if you are not satisfied with the amount of information you got with this instrument, and if you are really a hardcore user, you can use the shader analyzer. So what it is, in order to use shader analyzer, you have to install NVIDIA Texture Tools, and then you just need to run the debug analyze shader function, and it will give you this detailed output on all the shaders available in the scene. So why I'm saying that this is a hardcore approach, because you need to understand how GLSL shaders really work. But if you have such knowledge, you can really get the info about all the operations used in your shader. So this is the most precise approach to determine the complexity of your shaders. So that's it. I hope it was something interesting for all of you guys. Obviously, there were no miracles in my presentation. Anyway, thanks for your attention, and any questions?
Please, your questions.
My question is about video codecs. We try to implement some video texture in our project, but unfortunately we cannot find any codec that will work on any platform. Internet Explorer, Chrome, Firefox, WebKit on mobile, on Android and iPhone. Is there any?
Well, MP4 is a good approximation. MP4, yeah, it doesn't work on every platform, but for this case, as I have mentioned previously,
So we can make a logic switch, and for one platform use one video, and for others other video.
And the cool thing is that you do not have to. Blend4Web will do this for you. Yes, you just get all the converted formats just after pressing the convert resources function, and then depending on your platform, Blend4Web will choose what kind of format to use. So when you run the converter, you get MP4 for OGG and WebM, and vice versa. You get something.
So
I don't remember.
Blend4Web player choose right file and plays it on corresponding device.
And if you have all the files available, it will run on any kind of application, any kind of browser and platform. Yeah.
Great.
Okay, who else?
Yes, I have a question about CLI. Can we run export algorithms to JSON from .blend file, not from Blender, just from some CLI script?
Yes, for this case, we are using the project manager script as well. There is a detailed instruction in the documentation available. If you need it, we can give you a link. So it also can be done. Maybe just you need to tweak a little bit some paths. But anyway, this can be done, yes.
Thank you.
Thank you for showing these strategies, quite helpful. Maybe mine is not a question, just for talk. One of my workmates run a script that can use Arduino to control the skeleton in Blender. That's quite helpful for us to do animation in our project. Actually, for me, I always do the Blend4Web things transform into WebGL. I like the quick view method, but you know, every time when I change the skeleton, then it should still need to redeploy or use the fast view to check it. So is it possible to just use hardware to control the skeleton in a WebGL demo? I'm not thinking about this very deeply, but I think when I export a skeleton animation, it will be automatically baked. Is that true?
What is skeleton? I don't know.
I can share those papers later, but it's just like if I apply a skeleton to a human body in Blender, and we developed a kind of hardware use Arduino that can communicate with Blender. Every time, like that, if I build a human-like skeleton, I change the skeleton of Arduino, then it can automatically send the data into Blender, but it can't be sent to the WebGL demo.
You mean you want to send some info with some protocol to a web browser with skeleton? Well, you can use the server side for this case. I have no pre-built solutions, obviously. So, yeah, some coding will be required for this case. So, yeah, we don't have pre-built solutions yet.
Okay, thank you.
No problem.
More questions, please. Any questions online? No? Okay, thank you, Evgeny.
Thank you, guys.